All right, stats. Welcome to the first instructional video of fall 2020. Looking like I'll see you in person twice a week. So anything that is definition filled and whatnot, I kind of would take care of in an instructional video. I want to use those times in class to do kind of the more arithmetic, all right, the crunching of numbers with stats. So that's what we're going to do day one. I'm going to hand this packet out to you, and I'm going to say, hey, there's a video online where I explain all these definitions and whatnot. Anyway, introduction to stats, math 141, I believe it's what it's called. We are now using Lincoln Land. Chapters 1 and 2, chapter 1 of the old book I was using, and I'm really... our first semesters match up really nicely. We have changed books, but I'm probably just going to keep the chapter titling as it was before. Anyway, this is essential definitions. You'll have this packet in a few weeks. Packet week 1, fall 2020. Just want to go through this. Most instruction videos I'll make with me working things out at the board, but this one only has a single pie chart so that we're going to make by hand. So, I don't think you need to see me. Anyway, important definition. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. Measure of confidence, level of confidence. That's going to be huge for us later. The entire group to be studied is called the population. United States voting adults. An individual is a person or object that is a member of the population being studied. Could be you. And a sample is a subset of the population being studied. All right, they sampled 1,007 adults. A statistic is a numerical summary of a sample, SS, alliteration. Descriptive statistics consist of organizing and summarizing data. We're going to do that early. Standard deviation, box plot, 5-number summary, mean. Descriptive statistics describe data through numerical summaries, tables, and graphs. I love them. Then, in the second semester, we'll talk about inferential statistics. Uses methods that take a result from a sample and extend it to the population and then measure the reliability of the result. Okay, so we use stats to make inferences about something. A parameter is a numerical summary of a population. Look at the alliteration again. Statistic, sample, parameter, population. A variable is any characteristic of an individual. A variable can take different values for different individuals. Two different types of variables, qualitative or categorical. We'll call that we'll probably use categorical in chapter 1 for us. Variables allow for classification of individuals based on some attribute or characteristic. All right, major, male, female, day of the week, you know, what type, month of the year type of thing. Anyway, you can't really do any a zip code is another one we'll talk about. You can't really do any math with it. Telephone number, you just, or really area code. Quantitative variables provide numerical measures of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results. Okay, you can't take the area code of St. Charles, Missouri area 636 and subtract the area code in Edwardsville 618 to get anything that is, anything that's useful. All right, so categorical variables there. Whereas quantitative, you can do something important with. So determine whether the following variables are categorical or quantitative. So your temperature, you can take a 7-day average of your temperature, okay? That is quantitative. The mean, the average, means something. You can subtract. If you had a 103-degree fever one day and a 98-degree temperature, you have a difference of 5 degrees, and that does mean something. Gender, that's categorical. Number of hours, the past, not month. Oh, sweet. And I made a bunch of copies of this. Oh, I haven't yet. I guess I have time. The past month that a college student has studied. Okay, number of hours. So I can find the average, range. That's quantitative. Zip code is categorical. So if I take my zip code 62034 and I take your zip code, which I believe is 62056, you know, if I find the average of those, that doesn't mean the average is the town right in between us. No, no, no. Okay, so there's not, you know, not much to be done there. You just put in categories, okay? Put that in a category. Salaries of employees at a certain bank. Quantitative, I can find the range, I can find the average, add and subtract, high salary minus low salary, and so forth. More information about variables on the next page. Get pumped. All right, this is new to the chapter 1 now. A discrete variable is a quantitative variable that either has a finite number of possible values, you can count them, or a countable number of possible values. All right. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any two values. Okay, it's 1 or 2. It's not 1.21, it's not 1.59, so forth. Here are examples of discrete variables. Write these down. Number of students in first hour. 1 student. 7 students. 8 students. Not 9.2 students. A student's grade level. 9th, 10th, 11th, 12th. You're not in 11.5 grade. I don't know if you heard my daughter there. She's not agreeing with nap time. Number of heads when flipping 3 coins. 3 heads, 2 heads, 1 head, no heads, not 2.5 heads. All right. A continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between any two values. Believe it or not, height is one. You could be 5'8", which is 68 inches. You could also be 5'8.1". I mean, when you take your height, you really are just rounding. So you could be anywhere between 68 and 69 inches. Really has an infinite amount of, you know, possibilities for height in there. So that is an example of a continuous variable. Heights of students in class, weights of students in class, distance ran in a day, again, decimals. 9.5, 9.51, 9.52, 9.97, 10.01, all different distances. All right, quick discussion on levels of measurements. We're not going to do a ton with this, but this is an FYI. A variable is at the nominal level of measurement if the values of the variable name, label, or categorize. In addition, the naming scheme does not allow for the values of the variable to be arranged or in a ranked or specific order. Male, female, smoker, non-smoker, so forth. All right, categorize. That should look familiar from the previous page. Can't rank them or put them in any order that means anything. Now, a variable is at the ordinal level of measurement if it has properties of the nominal level, so up above, put in a category, measurements. However, the naming schemes allows for them to be arranged in a certain order. Economic status, low, middle, high. All right, high, middle, low. And letter grades, A, B plus, C minus. I mean, the ranking of those better. You would rather have a B minus than a D plus. All right, ordinal level. And everything in this class is highly Googleable. All right, so you can write yourself some more notes if you please. Variables at the interval level of measurement if it has properties of the ordinal level of measurement. And differences in the values of the variable have meaning. A value of 0 does not mean the absence of a quantity. Okay, FYI. Arithmetic operations such as addition and subtraction can be performed on values of the variable. So, an example would be temperature. It's not ratio as ratio of temp. We're going to talk about ratio in a second. It's not ratio because ratio of temp does not represent a meaningful results. All right, we'll talk about that in a second. ACT, SAT scores. So if you look at how many questions right you got to get a certain score, you know, I know that if you get 30 questions right on the math ACT, you're going to get a 21. If you get 45 right, you're going to get, you know, like a 27 or a 28. So if you get 45 questions right, you got 15 more. You did 50% better as a percentage score, you know, 45 out of 60 versus 30 out of 60. You can figure out the percent difference there. Whereas, you know, you wouldn't say, oh, I got a 28 and you got a 21. I did, you know, 1.3 times better on the math ACT. It's a different sort of ranking there, but the ranking does make sense. And you can say I did do 7 points higher on the math ACT. Let's take a look at the last one, because that last one says arithmetic operations such as addition and subtraction can be performed. Notice I didn't include multiplication and division. That would put a variable at the ratio level of measurements if it has properties of the interval level of measurement and the ratios do have meaning. A ratio of 0 means the absence of a quantity. Arithmetic operations such as multiplication and division can be performed on the values of the variable. Height, weight. All right, if someone is, let's see, 36 inches tall, they are half of the height of someone that is 6 feet tall. Same thing as weight. Okay, if someone is 80 pounds, they're half the weight of someone that's 160. Duration of time, if you run a 5K in 40 minutes and somebody runs a 5K in 20 minutes, you have taken double the time. All right. Variables that are nominal or ordinal are categorical, and variables that are interval or ratio are quantitative variables. All right, and honestly, that's about it with the discussion on those. Okay, pie charts show the distribution of a categorical variable as a pie whose slices are sized by the counts or percents for the categories. A pie chart must include all the categories that make up a whole. Use a pie chart only when you want to emphasize each category's relation to the whole. All right, so here's an example for us, and this is one that you should probably be able to do on your own. I will stop this first video right here. So let's talk about shots made in basketball. 1 point is a free throw. 2 points is a 2-point field goal. Okay, and then a 3-pointer. So that's how many different shots a player made. That's a decent amount of points. So if you play basketball, that can be you. Notice it's important to write down what that total is. This plus this plus this should be 151. All right, and that might be a good place to stop this first video. This is Yak Math Videos for a moment, signing off.